Now in this video, I'm going to go through a quick example of how we may apply our buoyant forces here. So let's say our foundation elevation is 99.2 meters, our high water line is at 100 meters, and we're using an abutment with an A4 anchor. As shown in the little diagram here, our overburden area and where the high water line might fall along that. So for uplift, we can calculate our buoyant force as our width of that anchor of 3 meters. Remember, this is our density or our unit weight of water converted to kilonewtons with 9.1 over 1,000. And then this is going to be our area. And this looks complex, but I'm just using the area of a trapezoid equation to calculate the area, the cross-sectional area of water that is being displaced. Remember, we're multiplying that by the width of the anchor and multiplying by its unit weight to get a buoyant force of around 30 kilonewtons that we would then subtract from our uplift resistance and use a factor of safety of 1.25 because in this case, this is just the high water line that might be temporarily rising over the anchor. For sliding, let's let our back wall to center line distance be 10 meters, and we can calculate our buoyant force similarly as our unit weight times width times our, say, length and height of that water. And remember, we can reduce this this value for soil, but in this case, we're conservatively going to assume that all of the water is displaced and we get a buoyant force of 235 kilonewtons. So feel free to work these problems out on your own. This just wanted to put some numbers to the situation so that you can put it in the context with some of the other design values you may have.